Hello, and welcome to solving exponential equations. This is going to be an intermediate algebra view of it, so they're going to work out a little bit better than some of our other options later on, like in the college algebra lecture series. Okay, so how do we do this? To solve an exponential equation, we have these 4 steps. First, we're going to isolate the exponential part on one side of the equation. So we have to get the exponential part completely by itself, just like we did with the squared part or the absolute value. We always isolate whatever type of equation it is that we're working with. Then we'll take the common logarithm of both sides of the equation. Then we'll use the power property for logarithms to bring the exponent down to the front of the logarithm. And then we'll solve by isolating the variable. Let's see what that looks like. So first, we want to isolate our exponential part. So let's subtract 10 from both sides. So we'll have 8 to the 4x equals 37. All right, that's step 1. Step 2, take the common log of both sides. And it's the common log is log base 10 because that way we could do it on our calculator. So when we take the log of both sides, we really just write log in front of both sides, because if two things are equal, then the logarithm base 10 of those two things are equal. It could be log base anything, but it's use base 10 because that's what we have on our calculators. Bring the exponent down in front. And I'm going to have to bring this back up over here. In order to isolate the x, what do we divide by? We're going to take this log of 37 and we're going to divide it by the 4 and the log 8. So we're going to divide by both of those parts. We'll have 4 log of 8. Now this is our exact answer. This is a great answer. But if you told somebody that you need to borrow log of 37 divided by 4 times log of $8, they'd look at you like you might need to be put away for a little while, get some medical help. When you divide, make sure, since it's 4 times the log of 8, make sure you use parentheses to put the entire denominator in one thing. If they wanted to borrow that much money from you and they only needed 43 cents, how annoying would that be? 4, 3, 4, 1, 2, 1, 1, 1, 3, 8. Round to 3 decimal places, so let's make our answer 0.434. Alright, don't make it any more complicated than it needs to be. Alright, I'm going to leave that there. Let's try this next one. I kind of want blue. Let's use blue. There we go. So we want to isolate. Let's label these. Isolate. So let's divide by 5. So we'll have 5 times 3 to the x plus 7 equals 30. And we want to divide by 5 to get 3 to the x plus 7 equals 30. Now we want to put a log in front of each one. So that's log of 3 to the x plus 7 equals log of 30. And I'm trying to do better at using my parentheses appropriately. So this is step 1. Step 2, take the common log. Step 3, we're going to bring that exponent, that x plus 7, all of it. So we use parentheses out in front using the power rule. Now there's a couple of different ways we could do this. And I'm going to go with what came to my mind first. We want to isolate the x. So why not first divide by the log of 3? Right? Get that x plus 7 by itself. And then finally, we can do our division and subtract 7. And we could get our decimal approximation. So now we enter in our calculator. I will never expect you to know how to do a logarithm in your head. We used to have tables for such things, but not anymore. We have calculators. We end up with a negative 3.9040962726. And if we're rounding that to 3 decimal places, we're going to call that negative 3.904. And we have our answer. And we can always check this too. I'm going to store that value for x in my calculator. And then I'm going to type in this problem exactly as it's written here. 5 times 3, close the parentheses, to the power of x plus 7. And on my calculator, I can see that it's in exponent form. If you need to use parentheses after your caret, you should do so. Hopefully this is 30. Let's see. 150. What did I do wrong? Oh, well, look at that. Now, normally, what I should do is erase the video, delete the video, edit it, make it look good. But mistakes happen. They happen to all of us. 30 divided by 5 is 6. So I am so glad I decided to check this answer because it was wrong. So that's the nice thing about math, is that if you do make a mistake like this, honest mistake, I really didn't do that on purpose. I'm frustrated by the fact that I did that. It looks like, and I'm gonna read this out. With a log base 6 divided by log base 3 and then minus 7, I think now the answer is x equals negative 5.369. But before I circle that, I'm going to store that for x and make sure I did it right this time. I can't believe I just forgot to divide 5 times 3 to the x plus 7. Much better. And now I'm confident about that answer. And that's why it's important to always check your work. All right. So don't forget, 30 divided by 5 is 6. I know if we'd been in class, you would have told me earlier, but you had to watch that painful thing. Me calculating that for you. All right, let's do it again. We're going to isolate. Already done. You know what I'm thinking? I look at 264 and I'm thinking, hey, maybe that might be a power of 4. I want to check it out. What's 4 to the 5th power? That's too much. What's 4 to the 4th power? Oh, look at that. And I just guessed. I happen to know 4 to the 3rd is 64, so I went bigger. 4 to the 4th power is 256. So we could use the equality property of exponentials. So we could do 9 halves, which we know is 4.5, and I'm pretty sure this is right. But what if we did this other method? All right, take the log of both sides. The log of 4 to the 2x minus 5 equals the log of 264. All right, we didn't have to divide or anything first. We use our power property. We use our power property in order to bring that exponent down. And then we divide. Let's take 2x minus 5. We'll have log of 264 divided by the log of 4. We're going to add 5. Bring it up over here. Add 5 to both sides. And finally, we're going to divide it all by 2. So I'm going to throw a 1/2 in front of this. Right? Instead of dividing by 2. We can multiply by 1/2. Oh, let's take that one back. And how am I going to put this in my calculator? I'm going to do it a little bit at a time. I'm going to take care of that fraction. I'm going to do the log of 264. Make sure I close my parentheses, divided by the log of 4. And then I'm going to add 5. Let's make sure I add. And then I'm going to multiply the whole thing by 1/2. 4.511098. There we go. Now, what's up with that 1 when it should be just an even 4.5? We know from the 1-to-1 rule. And that I can't answer for you. It's too early in the morning for me to be able to answer that. It should be 4.5. That's the answer I would go with. I'm looking 264. I have that number correctly everywhere. 264, log of 4, add 5, multiply by 1/2. They should be the same. Okay, that's driving me nuts. I'm moving on. All right, so we're going to take the logarithm of both sides. Already isolated. We'll use the power rule to move that exponent out in front. Trying to reinforce good notation here, use parentheses. I want the x by itself, so we'll take log of 5.6 and divide by the 3 and the log of 5. Now, remember, when you have more than one thing, if you have addition, subtraction, multiplication, or division, something going on in your denominator, always use parentheses when you put it in the calculator. So this will be log of 5.6. Close that parentheses, divide it by, parentheses for the denominator, 3 times the log of 5, parentheses closed for the log and for the denominator, to give us 0.35685. So we'll go with 0.357 for our answer. Let's check it out. All right, is this answer correct? Store for x. Now I'm just paranoid. 5 to the power of 3x. 5.6. Fantastic. If you can check your answers quickly and easily, like say using a calculator, you should always do so. That's the best part about math. History, you can't go check it out unless you have a really cool phone booth and can get places. All right. Isolate. So we'll divide by 2. Why do we do that? Why do we isolate first? Remember, in the order of operations, because this 8 is kind of tied up with the exponent x minus 2, we can't make it past this line. We can't go past there. So we can't multiply, we can't divide, we can't do anything to that 8 because it's all tied up with an exponent. So if we can't multiply that 2 times 8 because the 8's all busy over here, let's divide by it. Let's just get it out of the way. And then we could take the log of both sides. And then we can move our exponent out in front. Let's take it up here to the next row. I'm going to divide by log of 8. And remember here, we're dividing by the log of 12 divided by the log of 8. We're not dividing 12 by 8. It's the log of 12 divided by the log of 8. The logarithm is very important. It does something to the number. It's a function unto itself. And what is our answer now? We have the log of 12, close the parenthesis, divided by the log of 8, close the parenthesis, add 2, and we get 3.1949875. rounded to 3 decimal places. That's 3.195. And again, we could check it. Hey, check this out if we're going to check something. I could do natural log instead. Natural log of 12 divided by the natural log of 8. And then I can add 2. And I get the exact same answer. Right? As long as I use the same base for each of the logarithms, it doesn't matter what base it is. So I use common logarithm all the time because it's the common one. It's the one most frequently used. It's also the one most frequently on calculators. Unless you have a TI-89, then you'll have a natural log button, but not a common log button. And so maybe you want to use the natural log instead. Adapt to your calculator when necessary. All right, the last one. Isolate. So let's add 9. Take the log of both sides. Bring the power down in front using the power rule. And isolate the variable. So we start by isolating the exponential part. We end by isolating the variable. And what is this? This is log of 30 divided by the log of 3. Keep in mind 30 divided by 3 is 10. This is not 10, right? The logarithm does something to it. Put down the whole answer, and then remember, we're rounding to 3 decimal places. So this 5 gets rounded up to a 6. And we have our last answer. So when it comes to solving exponentials, isolate the exponential part. Take the common log of both sides, solve for the variable, throw it in the calculator to get your decimal approximation. This is my exact answer. Exact answers are awesome. The decimal approximation is actually that one. Right, decimal approximation. So the exact answer, that's a fantastic answer. That's what you put into your calculator. The decimal approximation is what comes out of your calculator. So watch for those. Make sure you read the instructions on the assignment, my students. Are you rounding or are you giving an exact answer? That's it for this video. Thanks for watching.